Okay. Hello everyone and welcome to the course. Welcome back to the course, Python for Data Science. Last class, yesterday we talked about operations, arithmetic operations in NumPy. We also talked about some universal array functions that you can use, irrespective of which kind of array you're using in NumPy. So these are functions that you can use on certain arrays that you create. Then we had module 3 practice exercise. So we'll first discuss this practice exercise, then we'll move on to completing Pandas. And if we have time today, we'll move on to module 5, which is matplotlib, which basically helps us in plotting. So first, basically what we need to do is we need to import numpy as np, okay, because we're going to use it. So the first question is create an array of 10 zeros. So there's a straightforward function to do this, np.zeros, and then we give it the dimensions, in this case, which is 10. So we get an array of 10 numbers, all of which are 0. Okay. Next question is how to create an array of 10 ones. So basically, instead of zeros, we have np.ones. So now it will create an array of only ones. Then the next question is create an array of 10 5. So here what we can do is we can just create an array of ones and then multiply it by 5. Okay, so that's one way to do it. Another way to do it would be we create an uh, array of just zeros and then we add 5 to it. That will also give us the same result. Okay, the next question was create an array of integers from 10 to 50. So we are here using the arange function in NumPy, which basically takes the argument of start and stop. So the stop, remember it stops right one before whatever you provide here. So this goes from 10 to 50. Okay. Create an array of all even integers from 10 to 50. So we'll again use the arange function now with steps. So we start with 10, which is even, and we want to get all alternate numbers from there on. So 10, 12, 14, 16, and so on till 50. Okay. Next question is create a 3 cross 3 matrix with values ranging from 0 to 8. Let me just run all these again. Oh. So now we have to create a 3 cross 3 matrix with values that range from 0 to 8. So basically we'll have values from 0 to 8 that we can get by using the arange function. But this will give us a one-dimensional array containing the number letters from 0 to 8, numbers from 0 to 8. Now what we need to do is we just need to reshape it to 3 into 3. So that's what we get. Okay. Create a 3 plus 3 identity matrix. So we have a function in NumPy for that, np.eye, which just gives us a identity matrix of the dimension that we provide. Always remember that an identity matrix is a square matrix. So you just need to give a single number here, 3, 4, or 10, or whatever. Okay. Use NumPy to generate a random number between 0 and 1. So this we can do using the random submodule in NumPy. So np.random.rand1 will basically give us a random number between 0 and 1. In this case, we get 0.64. Okay. If we run it again, we'll get a different value. See, but the value will always be between 0 and 1. Use NumPy to generate an array of 25 random numbers sampled from a standard normal distribution. So if we write rand n, then it samples from a random normal distribution. If we just write rand, it generates from a uniform distribution. So every number is more likely to occur. But in this case, we are more likely to get numbers in and around 0 because the standard normal distribution peaks at 0. Okay. Uh, okay, so we'll just look at the exercise files also so that we have an idea of what we want to create here. So the first one is create the following matrix. Okay, which is basically 0.01 to 1, all the numbers. So what we can do is we can just arrange from 0 to 1 in steps of 0.01 and then rearrange it into this shape, which is I think 10 by 10. Yeah. So we are just np dot arrange we are doing 0 to 100. Then we are reshaping. So now we'll have values from 0, 1, 2, 3, 4 till 100. Okay. Then we are basically dividing the whole thing by 100 so that we get this decimal point here. Right. So this generates the desired output that we want. Create an array of 20 linearly spaced points between 0 and 1. So we can basically use the function linspace, which gives us linearly spaced points between 0 and between whatever two numbers we choose, and how many numbers we want, we have to indicate here. Now we'll get 20 linearly spaced numbers between 0 and 1. Okay. So we are given this matrix, which is basically a matrix from 1 to 25, arrange 1, 2, 3, 4, and so on. So we need to recreate basically this thing, which is a part of the matrix. So basically from this 12 to 25. So basically second, third, fourth, fifth rows and columns and third, fourth, fifth rows. So we are just indexing it that way. So this starts from the third row because indexing starts at 0. So 0, 1, 2 will be this one. And this starts from the first column. Column of index I. So basically 0, 1 in the second column here. We should get 12 to 25. Just those numbers. Okay. Next, we are asked to extract only 20. We'll see 20 where it is. It's basically in the 1, 2, 3, fourth row, last column. So basically what we can do is 3 and 4, which is basically the last column. We get 20. Next question, we are asked to get the array 2, 7, and 12. Let's see where it is. 2, 7, and 12 is this one. So we just want the second column and we want the first three rows. So what we'll do here is we'll select the first three rows 0 to 3 and then we just want the first second column which is at 0 index. Sorry, at 1 index. And this 2 here will stop, like will not execute because there's a stop and it always stops before 1. It will be from 1 to 1. If I write here 3, it will be from 1 to 2. Okay. The answer here will be this. Next, we just want the last row, I think, 21, 22, this last row. So what we do basically is we just select the last row and then we put a colon here because we want all the columns. Basically, both sides of the colon are blank. Right. Next, we want the last two rows. So similar to here, we just do 3 to 5, which will be 3, 4 indices. And on the right hand side, we just have a column because we want all the columns. Okay. Get the sum of all values in math. So basically, we can use a array function in NumPy called sum to get the sum. So basically, you have any array or matrix or any kind of one-dimensional, two-dimensional object, then you just put the function sum after it and you call the function and you get the sum. Similarly, for standard deviation, which is the next question, we put array.std, which will give us a standard deviation. And to get all the sum of all the columns in the matrix, what we'll do is we'll use the function sum, but we'll put axis equal to 1. So now basically it axis equal to 0. So now it basically sums up all the columns. If you put axis equal to 1, it'll sum up all the rows. This is the sum of the columns. So that was it for module 3. In module 4, we discuss about pandas and uh, how it helps us create and maintain data in the form of different easy to use data structures with a lot of available tools. So we talked about the series object, how to create a series, how to put data in series and like use an index to get data from the series. Okay, we also talked about some operations in series. We talked about data frames, which is the major data type in Pandas that we'll be using for most of our things. Okay, we talked about the data frame, how to create a data frame, and then how to index and select from a data frame. Okay, how we can add new columns or remove columns from a data frame, how we can uh, add or remove rows, select columns, and select a subset of the data. We can also use conditions to select uh, data based on the values that we have in columns or rows. Okay, all these things we talked about. We also talked about adding, like, combining two different conditions to select data using and or. Okay. Then we talked about resetting an index, setting a new index, and like uh, what is basically a multi-index and how it works, how you can get uh, select stuff from multi-index data, how you can select stuff from multi-index data and like change stuff and also set and reset those indices, multiple indices, how to work with them. Then we also talked about data input and output, how you can use pandas to read CSV files and to create CSV files or Excel files, where you can read data in tabular format from Excel files and uh, output it to Excel files. Okay. We also talked about how we can basically deal with some missing data that we might have um, in our data set. Basically by removing those data or dropping basically specific columns or rows with a given threshold of NaN values. Then how we can fill a NaN value with another value, and how we can use metrics such as mean to fill Na with the mean of the row or mean of the column, and so on. Okay. Today we'll look at operations in pandas. Okay. Mm. So we'll be talking about a lot of operations uh, that will be kind of useful for you in data science, but they don't generally fall into very distinct categories. So they're all clubbed together here. So let's say import in pandas, and I have a data frame, which basically looks like this. Okay, so we have three columns here and four rows. The first two columns have numeric data and the third one has string data. So we can use the function uh, dataframe.unique or series.unique to get basically what all unique data is there in our series or is there in our uh, data frame. Okay. If we use the function nUnique, it gives us how many unique values are there. Not the values, but how many unique values are there. There's another function called series.value underscore counts, which basically counts all the number of times a given value occurs. So let's say in our series here in column 2, we have 444 twice and 555 and 666 once. So it basically gives us the count. So 444 occurs twice, the rest to occur once. Okay, is that clear? Great. Then uh, we move on to selecting data, which we looked at slightly before also. So here basically we are creating a new data frame from our data frame, and we have two conditions where column 1 is greater than 2 and column 2 value is 444. So we have an and here, so this will only execute if both of these statements are true. So we'll get a new data frame based on the condition. If you print it out, it just has one column, the third column. Okay. Similar to uh, and similar to NumPy in a way, we can use built-in functions that are there in the Pandas library on series objects directly. So for example, here we are getting the sum of column 1 by putting dot sum behind the name of the column. Okay, so this function will give us the sum of all the objects in column 1. So let's say what is, we just take a look at what column 1 is. It's just 1, 2, 3, 4. So the sum is 3. Okay. We can also use something called apply, which is basically a special kind of pandas function in data frame and for series. So it helps us apply a given function to all the values in a given series or data frame. So let's say we have the column 1, which is 1, 2, 3, 4. We have a function called uh, up- times 2, which basically returns the number twice the value of the number. So if we apply this function using the function dot apply, and we pass a function in here in the argument, so it applies the function to all the elements of column 1, and what it returns is the result. So basically, we had 1, 2, 3, 4, which now became 2, 4, 6, 8, because our function just multiplies the number by 2. Okay. We can apply pre-built functions such as len and all. So this basically gives us column 3, what is the length of each item. So let's just check what column 3 was. Column 3 was the string characters. All of them had 3 characters. So the length here are 3, 3, 3, 3. Okay. If you want to remove a column without using the drop keyword, you can also do delete, del, and then specify the data frame and the column. Now, basically, the column is deleted from the data frame. Note that we don't have to use in place is equal to true or anything like that here. This basically deletes the column from the data frame. And you can similarly delete a data frame using the keyword delete. Okay. To get column names and index names, we can use df.columns, which basically gives us name of columns. And to get indexes, index, which is the row name, basically, we use df.index. So it's basically a range index starting from 0 to uh, ending at 4. So basically 0, 1, 2, 3 at steps of R. Okay. So now we have a data frame, which is slightly modified. We lost the column 1 a while back. So we can sort a data frame using a method in Pandas called sort underscore values. Okay. Here again, you have to use the keyword in place, otherwise it won't modify your data frame as such. It will just return a view of the data frame, modified view of the data frame. Okay. So basically df dot sort underscore values. Then we have a argument here called by, which should be what uh, column you should use to sort the values. So basically now if we are using the second column to sort the value, so this 444 should go up and both of these should come down. Let's see what happens. That's exactly what happened. So this 444, the exercise that we had here, it went up because now we are sorting based on ascending value from column 2. Okay. We can also check if there are null values in a data frame, null or NA values. So if we type daf dot is null, it basically gives us if there is a null value in a data frame anywhere. Again, as mentioned before, we can use the df.drop NA to drop rows with NN values. Since we don't have any, no rows have been dropped. Okay. Uh, as mentioned, using the df.fill NA function, we can fill a data frame with NA values with whatever. Uh, so hmm, we can fill whatever NA values that we might have with whatever value that we want to fill. Basically, here we have filled the NaN values with 3. literally fill. Uh, then there's a function called pivot. So basically what pivot does is it changes our indexes. Okay. So let's say we call the function pivot underscore table on a data frame. We give it what values, which column to treat as values. So here the column D will be treated as values. We ask it which columns to treat as index and which one to treat as column. So basically we are changing the structure of the data frame. Now A and B will become our indexes, C will become our column, and we'll have values from D. Okay. So A and B have become our indices. It's a multi-index thing now. C has become the only column in the data set, and the values for C, which is X and Y, are reflected here, X and Y. And all the values for D are taken as uh, values for uh, the cells. So basically, we have here bar and here 1. Okay. And we have here X, and the value is 4. So bar 1 X, the value should be 4. Similarly, bar 1 Y, the value is 1. Bar 1 Y, the value is 1. Okay. Here we are getting an NA. Let's see why is that. So the value is bar 2X. So let's look for bar 2. We have a bar 2, but we don't have bar 2X. That's why the value here is NA. Similarly, we don't have a foo 2Y. We have a foo 2X, but we don't have a foo 2Y. Okay. Pandas has a very powerful method called groupby. Okay. Which basically allows you to group lots of data together, like some rows of data based on something, and then call aggregate functions on it. So let's say we have a data frame here. We are creating from this data. So we have three columns, company, person, and sales, and we have values for those columns. So this is how the data set looks like. So basically what company someone works for, what is their name, and how much sales they have been doing. Okay. Yeah. So now we can use the dot group by method to group rows together based off of a column. Okay. For instance, if you wanted to see uh, what all people are there in like Google, what all people are there in Microsoft, or what all people are there in Facebook, we want to group it by company. So what we do is df.group by and we give it company. Okay. So basically this returns a group by object to us. Okay. So we'll have to basically assign it somewhere and then basically yeah, we don't assign it. So this gives us a group by object which is like a iterable object, like we have zip and all the objects that they return. So this returns an object that we cannot directly read. Okay. But we can apply it to like we can apply aggregate methods on it. Okay. So now we have the data frame company and sales. We are just taking those two columns and we are grouping the subset of data frame by company. Okay. If we do df com company and sales, we basically just get the company and sales. We don't get the person or the name here. Okay. So that is the first part here. Then we are using dot group by to group it by company. Okay. So basically it groups these two rows as together, these two as together, these two as together. We store that into a variable called by company, by underscore comp. Then what we can do is by underscore comp, and we can call aggregate methods such as mean. So basically, this will show us the data frame, which is basically the mean of the values by company. So for example, Google here are two values, 200 and 120. The value here 160 is the mean of both of those. 120 plus 200, which is 320 divided by 2, which is 160. Okay. Similarly, we have for Facebook the uh, mean, for Microsoft the mean. We can also call standard deviation to get at standard deviations based off of company. We can get what is the minimum value of sales. So basically this for each company, whatever values it has. So Google has these two values, 120 and 200. It basically performs operations on those. So mean will basically take the mean of 200 and 120. Standard deviation will calculate the standard deviation of these two values using these two values. Minimum will return the minimum between these. Maximum will return the maximum between these. And count will basically give us how many values are there. Okay. So if we had more values from one company, we can see that here. Now we have two values for each. We can also use a method called describe. So if we describe this thing, it basically is a shortcut to give us everything. Okay. So it's all the companies, like the sales have been grouped together by company. Okay. So for each company, we get what is the count. So how many sales have been made or how many people are working there in sales. Then we have the mean for each company. We have the standard deviation. We have the minimum value. We have the maximum value, and we have these percentages, percentiles basically. Okay. So this is like median, this is 25th percentile, this is 75th percentile, and so on. Now, if we transpose this thing, we can get it like the rows and columns are basically interchanged. So transpose is a function which basically we also use in matrix multiplication and stuff like that. So it basically inverts your rows and columns. So the row values become column values and the column values become row values. Okay. Now what we can also do is after doing all this, we can select a company. So basically, if I want to select Google, want I want it this way, I want it vertically. I can do a transpose and I then select basically the name of the column. Now I get all the values for that column. Okay. So Pandas offers us three main ways of combining data frames together: merging, joining, and concatenating. Okay, we'll talk about all three methods. So let's first create a data frame. And we have two more data frames because we want to merge them, right? So the first data frame has A, B, C, D as columns, and we have row values. So basically it's A0, A1, A2, and so on. The second one also has columns and rows. It's A4, A5, A6, and all. And the third one is basically A8, A9, A10, A11. So basically all of them share columns, but the rows are different. Okay. We can do that by changing the index here. So the column values also we are changing the values here. The columns are constant, but whereas the index is also changing. So the row headings, the row index is also changing. The row names basically. Okay. So concatenation will basically glue together data frames that we have. Okay. So we do pd.concat, which is a pandas function, universal function. It's not specific to an array, the one we are using now. pd.concat, and then we give it a list of data frames. What it will basically do is it'll try to merge those data frames either vertically or horizontally. Okay. Since we have uh, here, we have not written explicitly, but the access value is taken as 0, access equal to 0. Okay. So what this basically is doing is, this is adding all of them vertically, one by one. Row, they're stacking up the rows. So df1 is first, df2 is second, df3 is third. We get a merged value. If we do axis equal to 1, what we get is it's trying to merge it via column. Okay, so now notice we have repeats of columns. Okay, because this ABCD, the new ABCD that is there in DF2, it's treating it as a different column and it is stacking columns. But the row numbers here we have 0, 1, 2, 3. In the second one we have 4, 5, 6, 7. So it just continues from there. And these values are filled up. The values that are not present in any of the data frames are NaN basically. Okay. One thing you should keep in mind is that if you are uh, so whichever axis you are trying to concatenate numbers, you should note that the dimension should be matching on those axes. Otherwise, it gets difficult. For example, if DF2 here had 5 columns or something, it would have been there would have been an error, or Pandas would have created a lot of nans. Okay. So just keep all that in mind. If needed, if you have some data that you want to piece together, but their dimensions are not exactly same or one dimension is same. So make sure you transpose one of them and like get it into the proper shape before merging it with another one. Okay. So let's say now we have two more data frames called left and right. Left has 3 columns, which is key A and B. Right has 3 columns, which is key C and D. Key is basically K0, K1, K2, K3. Okay, and all the other values are A0, A1, and so on. So basically, the column name and the row name combined together, mashed together. Okay, but note that the right data frame has CD, the left one has AB. Only the keys column is the same, and the index is the same. So the merge function basically allows us to merge data frames together in logic, which is similar to merging SQL tables together. Okay, so basically you can provide it a key based on which it will merge tables. So basically, if you want to merge it now, so we write pd.merge, we provide the data frames, we provide just two. Okay, and it asks us how. We put inner and we put on is key. On is basically the column that you want to maintain in both of them. So which is basically like something like if you had two data frames with marks of people from biology in one data frame and marks of people in chemistry in one data frame, their names would serve as key here. So you'll basically match the names and then stack the columns together so that if I get 35 in biology and I get 40 in physics or chemistry, whatever, I'll basically in my row, it should be under biology, it should be 35, and under physics or chemistry, it should be 30, 45, 40, whatever. Okay. So basically the on keyword here decides like which column should be preserved or which column should be looked up as index while trying to add these two, merge these two data frames. Okay. Inner is something that we'll come to in a bit. Okay. We'll see what it basically does. So if we run this, what it basically does is it does not copy the key column again because the key column values are the same in both of them. It just looks up those values and then puts the corresponding values accordingly. So here for key K0, we had A0, B0. Here we had C0, D0. It put A0, B0, C0, D0 in one column, which has K0 at the key as the key. Okay. So this is a very simple example to understand how merge works. Now we'll move on to a slightly complicated one. Okay. Now we have two data frames left and right. Okay. Again, we have A0, A1, A2, and so on. But now we have two keys. The first key here is K0, K0, K1, K2. In here, it's K0, K1, K1, K2. In second key, in the left wala cases, K0, K1, K0, K1. And second key in right wala cases, all K0s. Okay. So now we want to merge left and right. So we provide left and right. On, in the keyword on, we provide two column names. So we provide a list of column names. Basically, we have key one and key two. So both of those things will be uh, used to index both the data frames. Okay. Now if we merge it, we see that we didn't provide it any how keyword like before. We'll go about checking what happens when we provide how. So without how, if we do it, we just get all the rows that are common. So basically key 0 is present here. Key 0 is present here. So those rows of values are taken and merged. Okay. Key 0 is here, key 0, and we have key 0 here. So here we have A2, B2, key 0, we have C1, D1, C2, D2. So it takes the first value first. So A2, B2 is there, A2, B2, K1, K0, which was here, A2, B2. Then we have C1, D1 here, K1, K0 mein, C1, D1. So that is the first row. The second one is a repeat basically. So we have mm, again we have K1, K0. We have A2, B2 here, which is just the one value. But here we have C2, D2. So we have another row with A2, B2, C2, D2. Okay. So this is how it basically works. It merges and takes whatever is common in both of them. And if there are repeats, it gets the repeats from both of them. All combinations of repeats, basically. If now we provide how is equal to outer, okay, what's happening here? So basically, we have K0, 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 K1, K1, K0, K1, K0, K2, K1, K2, K0. So let's check. Uh, let's first check left, what it looks like. So it has K0, 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 K1 also it has, K1, K0 also it has, and K2, K1 also it has. Okay. Now let's check right. It also has K0, 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 K1, K0. Okay. It does not have K2, K1, but it has K2, K0. This K2, K0 was not there in the left one also, but is there in the right one. So this outer, what it basically does is it takes all combinations of key values that are present. Okay. And then it just copies down values as before. So since we have two repeats of this K1, K0, we get two values here. Since there is just one value here to take, A2, B2, it just takes A2, B2 in both cases, but here it takes different values, C1, D1, C2, D2. Okay, this is how outer works. Note that we have a lot of NaN values here because this K2, K0 is not present in the left wala data frame, K2, K0. So AB values are NaN, and this K0, K1 are not, and K2, K1 are not present in the right wala thing. So these values have become NaN. Okay. Just delete this. Now, if we do key or if we do the merge thing and in the how uh, we provide the argument right, you can provide outer, inner, right, and left. Okay. So now we provide right basically. The default is inner. So this behavior that we saw first, this was inner, which basically takes all the common ones. Then we tried outer, which basically takes all the combinations of keys that are there and gives us NaN values also. Then we have right, which basically the second data frame that we provide here, right, it basically takes all the keys that are there in right. And it does not care if the keys are there in left or not. So basically the keys that we have here are K0, K0, K1, K0, K1, K0, K2, K0. All of them are in left, right. But if we check left, it has K0, K0, it has K1, K0, but it does not have K2, K0. And this K0, K1 is also not here. Okay. So it's basically taking values from the index of the right hand side or the second data frame that we are providing it. If now we use the keyword left in how, it basically does the opposite. It takes the values from the left data frame the first data frame that we provide here, and not the second data frame. Note that merge only works with two data frames at a time. So that's why the left one will always refer to the first one that you provide, and the right here will always refer to the second one that you provide. Okay. And then the last method to merge columns is basically merge data frames is basically using join. So again, let's say we have two data frames. We'll see what they look like. Left is this and right is this. So basically here we have a different index here. It's K0, K1, K2 for left, and for right it's K0, K2, K3. And we have values accordingly. We just have columns A and B in left and column C and D in right. Okay. Now if we do left dot join right, it basically joins the right data frame into the left data frame. So the keys that we have here are only the keys from the left, K0, K1, K2. This K3 is not there. And since the right data frame has no K1, these values are NN. Okay. If again, like we had for merge, for join also, we can use the how keyword to uh, how argument to basically specify how we want things to be merged. If we put outer, we get everything that is there in both of them. If we try left dot join right, this also basically works with just two data frames. And then how we put inner, it will basically give us things that are common to both. Okay, so inner data frame will never have NaN values because it will take rows that are, unless there are NaN values in your individual data frames. Okay, it won't have NaN values because it just takes all the common rows that are there. Okay, if, yeah, so that was it for pandas. We have another exercise for module 4, which is pandas. So I'll share this exercise with you people, with you guys over email. You can check it out, and then yeah, you can check it out and basically then solve it. Next class we'll discuss about this, and then we'll start looking into Matplotlib next class. So Matplotlib is basically one of the libraries that was developed by John Hunter, I think. Yeah, he tried to create MATLAB's plotting capabilities in Python using Matplotlib. So basically, the extension of Matplotlib is MATLAB plotting library. Okay, so this is what basically uh, it basically tries to emulate plotting and how we plot in MATLAB and all, and brings it to Python. It's quite versatile. It allows us to do a lot of things. However, it's also slightly limited. So we'll again learn about another. It's not limited as such. It's just that it's slightly difficult to master. So we have other subsidiary packages such as Cborn and all that help us do things neatly. So tomorrow we'll talk, not tomorrow, next class we'll talk about Matplotlib. We'll first discuss these exercises and then we'll talk about Matplotlib, which is great for visualizing data. It also it can help us make line plots, scatter plots, bar graphs, histograms, box plot, violin plots, and it also helps. It can also support. It also supports three-dimensional plotting, which can be all of which can be great ways to visualize your data. So yeah, so next class we'll do that. Thanks for being there. Uh, we'll meet next Thursday. Okay, bye.